Our last section for chapter 2 then is inequalities. So basically graphing a line, choosing if it's a solid or a dashed line, and then shading above or below. You guys should remember this from Algebra 1. So the only thing that's different might be tomorrow we'll add some modeling with real world, but I think we also did that in Algebra 1 as well. So a linear inequality is just an inequality in two variables whose graph is a region of the coordinate plane that is bounded by a line. And you can see the examples below of a linear inequality. Again, choosing your solid or dashed line, shading above or below. So when you're looking at the solution set, it's really the whole shaded region, which goes on forever and ever and ever off the grid too. So we're not getting just one answer, we're getting a lot of solutions. We will use a test point, which is a point that will fall in the shaded region to make sure that we did shade in the correct direction. So notice on the left, we have a dashed line. So if a point were to fall on the boundary line, if it's a dashed, it actually is not considered a solution. Just like when we graphed a single inequality on a number line where we put like an open circle and shaded left, that number wasn't included. The same thing goes with the dashed line. If you have a solid boundary line, that means that each point on the solid line is a solution. And kind of like our inequalities where we shaded left or right, when you see a less than or equal to, we are going to shade below or underneath the line. And a greater than or equal to will shade above. Now sometimes when the line is super steep, students have difficulty figuring out which is above and below. Some people don't have trouble at all, but a couple of people will have trouble determining if this is the above or this is the below part. Mr. Reiner always teaches to draw a little stick figure walking up the hill. Whatever side the stick figure is on, that would be your above part. So for example, this one, if I were to draw a stick person walking up the hill, he would be on this side. If you were on the other side, he'd fall on his head. So this part has to be the above, and this has to be the below. Again, some of you are going to look at me and be like, Mrs. Bennett, that's the easiest thing, I would never need to draw that, but there are some students when it gets super steep, they have trouble determining which is above and which is below. Okay, but we will pick a test point. So we'll pick a solution that falls in the region that's shaded, and we'll plug it in to make sure that it does work also. So there are some more detailed directions here for those of you that might need it when you're working on your homework. But essentially what you're going to do is you're going to graph the line. So we are going to graph the boundary line. If it's not in the form y greater than, less than, whatever, we will want to change it into slope-intercept form, but right now it is in slope-intercept form, which is our mx plus b. So we can see that the slope is 2, technically 2 over 1, right, because we'll go up 2 over 1, up 2 over 1, up 2 over 1. 3 is the b value, which is our y-intercept, not your x-intercept. On the quiz for 2.1 to 2.3, a couple of you were graphing the x-intercept. You are always starting on the y-axis. Okay? And again, we'll choose a solid line if it would be less than or equal to or greater than or equal to. We'll choose a dotted line or a dashed line if it's just less than or greater than. And in this case, we can see that it is a less than. So I'm going to choose a dotted line when I graph this. So let's go ahead and graph it. Start at the y-intercept. The b value tells you where to begin. So we start on the y-axis at 3. We use our slope, which is our rise over run, to go and move up 2 and over 1, up 2 and over 1. And that's probably enough to be able to use your popsicle stick or ruler to draw your line. Now be careful, a lot of students will take their ruler and draw a solid line, and then they're like, crap, I was supposed to make it dashed, okay? So if that happens in your homework, just write dashed along the edges, but on your quiz or test, I'd like you to use pencil. So if you do that, just go and erase little pieces of the line. Up here, I'm going to choose my dashed line tool. But you want to make sure that it is dashed. Because the points that are on that line are not technically solutions. And then we're going to choose our shading. So if it's a greater than or greater than or equal to, we do shade above the line. If it's a less than or equal to, we shade below the line. So based on the symbol I see in my inequality, I am going to shade below the line. So you can just take your pencil and just shade lightly. Oops. And then the last thing that you are supposed to do is to pick a test point, which is a point that falls in the shaded region, and we'll plug it in for x and y in our original and make sure that it is true. You can pick any point that falls in here. Does anyone have a suggestion of an easy point that would be easy numbers? 0, 0. If the origin falls in the shaded region, I always pick it because it's easy to plug in 0 and 0. So that would be 0, 0 for our test point. Again, this is x and y.
Any student who signed up for the Allegheny College visit, please report to the auditorium at this time. The Allegheny College visit.
So we'll plug in 0 for y, 0 for x, and 2 times 0 is 0. 0 plus 3 is 3. Is 0 less than 3? Yes. Now, the times you definitely want to make sure you pick a test point are on the back. You'll see we may have to solve for y and divide by a negative, which then makes us flip our inequality. So sometimes if you do your test point, you'll catch your algebra mistake in solving for the inequality before you would move on a quiz or a test. Okay, so that's really all we're learning today. We're just going to review some of the harder ones on the back that might not be in slope-intercept form. So example 2, we notice that it is in slope-intercept form. So we're just going to go ahead and start graphing our boundary line. So we have our y-intercept, which is 1. So we go to the y-axis. We put a point at 1. We use our slope to find more points. So I'm going to count up 3 and over to the right 2. Now since I can't come up with any more points from there, I'm going to go back to my y-intercept and I'll count down 3 and backwards 2. Okay, because -3 over -2 would divide out to be just 3/2. And then am I using a solid or a dashed line for this one? Abby? Dashed. Sometimes I even jot it down just to remind myself so I don't draw a solid line. And then once I do that, am I going to shade above or below this line? I'm shading above or below. Colton?
Above.
Good. We're doing above this time. We see a greater than. Now, I can't use 0, 0 as my test point this time because 0, 0 is not in the shaded region. You can pick any point that you want. Some students like to pick numbers that are on the x or the y axis so that one of the values is 0. So you might want to pick 0, 2, 0, 3, or you could also pick -3, 0. I'm going to pick 0, 2. Plug that back into our original. So we'll have 2 is greater than 3/2 times 0 plus 1. See how it's nice to plug in a 0? Because that way you don't have to do stuff with fractions. 0 times 3/2 is 0 plus 1. We get 2 is greater than 1, which is true. Okay. Now B, a little bit different. We do have, this is right now in standard form. You usually don't want to graph using intercepts. Remember how we used to show you could plug in 0 for x, plug in 0 for y, plot your two intercepts, and connect the dots. Well, that works all fine and dandy when it's a line, but when it's an inequality, sometimes you divide by a negative somewhere, and that would change your shading. So for the inequalities, I don't suggest plugging in 0 for x and y. I suggest that you solve for y And remember, if you do at some point divide by a negative, that you have to flip your inequality symbol. So how would I solve this for y? What would I need to do first to both sides? Gary? Good, we'll subtract 4x first. So I get 2y is less than or equal to. Now instead of putting 4 minus 4x, I usually put negative 4x plus 4 so that it's in slope-intercept form. And then of course divide by 2. On your homework, you may see ones where you're dividing by a negative 2. Again, that would cause you to flip your sign. This one does not though. Negative 4 divided by 2 is negative 2x and plus 2. Graph that, starting at your y-intercept. Now be careful, for the slope, when the slope is negative 2, it's really negative 2 over a positive 1. If this were a negative 1, these would divide out and be a positive 2. So when we count down 2, you are still going to the right one. And down 2 into the right one. This one will get a solid line because of the equal bar. And we will shade below that line. Test point, I would choose 0, 0 because it does fall in my region. Now, when you do your test point, you want to make sure you plug it back into the very first starting equation. Don't plug it into the one you modified, because if you modified this incorrectly, it's going to tell you you got it right, even though you may have gotten it wrong. So always test it back in the given, which would be 4 times 0 plus 2 times 0 is less than or equal to 4. 0 plus 0 is 0. 0 is less than or equal to 4. Now this does not always ensure that you got the problem right. It will ensure that you at least shaded in the correct direction. Okay, because again, there's a chance that you made a mistake somewhere and it still is shaded over that point. All right, see if you can try C and D. And we'll go over them. For D, you had to solve for y. So the first thing you're going to do is subtract 2, just like Caleb had showed. Now, when you see this x divided by 3, again, you need to remember that's really a 1x divided by 3 or a 1/3 x. So if you want, you might want to make it 1/3 x minus 2, less than negative y. If this were an equation, you can just like change stuff to the other side. But since this is an inequality, you have to keep everything on the left-hand side and the right-hand side as they are, okay, until the very end. Now, to solve this for y, I can divide by a negative 1. When you divide by a negative 1, you have to change the sign of every single thing. And we divided by a negative, which means I need to flip my inequality. So this would become negative 1/3 x plus 2 is greater than y. Now lastly, in order to graph appropriately, it should be y on the left, mx plus b on the right. So at the very end, I'm going to rewrite this by flipping it again to make it y is less than negative 1/3 x plus 2. And then you can see he started at 2, down 1 over 3. Since he ran out of spaces, he also went back to his y-intercept and went up 1 and backwards 3. Okay, dash line, shading below. And we should pick a test point for this one also, which I would pick 0, 0 since it falls in the shaded region. Remember to plug it into the original when you're doing your test. So this would be 0 divided by 3 is less than negative 0 plus 2. Negative 0 is still 0, so we're going to get 0 is less than 2, which does pass our test. So had you have shaded the wrong direction, because some people will forget to flip their sign, and you did your test point, you should show that the test point fails. And if the test point fails, it means you did something wrong. Don't just shade the other direction. Go back and recheck over all of your algebra. Okay. All right, the last one then, our closure asks us to write an inequality to represent the graph. Okay, so to write an inequality to represent the graph, we would need to identify the slope, the y-intercept, And then we need to pick out what symbol we're using, which that's usually the easiest part. Since it's a solid line and it's shaded below, which inequality symbol would I choose? Caleb? Good, I'm going to choose a less than or equal to. And we can see that the y-intercept goes through at 2. And what is our slope? What is our slope? It's kind of hard to tell. Remember, to pick your slope, we have 1 point. You want to pick another point that goes through grid lines. So this one doesn't go through a grid line. That one doesn't go through a grid line. But if you look at the tip of the arrow, it would go through right here, which would be at a grid line, the intersection of 2 grids. If I go up, this does not go through the intersection, neither does that. So these are the only 2 points that I could calculate my slope. What is the slope based on those, Gary?
3/2.
Good, up 3/2. Rise over run. So we throw that together, we should have y is less than or equal to 3/2 x plus 2.